Okay, find the coordinates, it says here, and nature of each of the stationary points on this curve. So remember, when we get stationary points, right, it's all about the maximum and minimum situation of the curve. Okay, so if I had a curve like this, okay, like that, the stationary points are at the top here and the bottom, the maximum and the minimum. Okay, and the reason why they're stationary is because you do sort of come to a stop, right? It's like a station. You know, if you were climbing the mountain, you would come to a stop at the top, wouldn't you? And you get to a situation then where the gradient is actually zero, if you think about it, because right at the top, if I was to draw a tangent right at the top, it would be a flat. It would be a flat line. Okay, the gradient zero. Positive before, and negative gradient after. So that means in the middle then we've got a flat gradient, which means the gradient is zero, isn't it? And the same way at the bottom. Okay, gradient is zero. Alright, so if the gradient is zero, that really helps us, because what we can do is we can work out dy dx, differentiate. We get 3x squared minus 6x. Okay, and then of course we could say, look, at stationary points, dy by dx is equal to 0. Okay, so in other words, 3x squared minus 6x is 0. Okay, because that's true, that's the gradient is 0. And then remember, dy dx is the gradient function, so we can put it equals to 0. And if it's equal to 0, we've got this here. Now we've got to solve this, okay, and we've got to look at somehow factorising it. Now if we were to factorise this, we need to appreciate common factors. So can we see x goes into both terms? X goes into both terms. Also 3 goes into both terms, doesn't it? So you could take out 3x, okay, and then bracket, and we'll ask, okay, what do we times by 3x to get 3x squared? So that'll be x. What do we times by 3x to get that? Well, it'll be 2, won't it? Or minus 2 equals 0. So we say, look, either 3x is equal to 0 or x minus 2 is equal to 0. If 3x is equal to 0, that means x is equal to 0, or then x is equal to 2. Okay, so we've got our 2 points there, 2 stationary points. X is 0, x is 2. But we do want coordinates, right? That's important. So we've got to work out what y is. Okay, so when x is 0, we work out what y by putting it into the curve, right? Remember, always put it into the curve to work out what y is. So y would be, in this case, we'll put 0 in, it would be 0 cubed minus 3 times 0 squared plus 11. So y would equal to actually 11. Okay, so my coordinate there would be 0, 11. And if I put 2 in, the other point, 2 cubed minus 3 times 2 squared plus 11. So that's the sort of thing you want to use your calculator for. Okay. And it comes out to be 7. So the other point then is 2, 7. So we write it as coordinates. Now we're not quite done, because it does say the nature, right? The nature of them. What we mean by nature is, well, we've got these two, right? But we don't know, we know they're stationary points, but we don't know whether they're a maximum or a minimum. Remember, you've got two situations. This is where we're at a maximum at the top. This is where we're at a minimum at the bottom. Okay? And the way you do that is, right, you've got to show, right, to get these marks here, because we've only got 4 marks so far, but to get the final 3 marks, we've got to show whether this is a maximum or a minimum. We've got to show whether this is a maximum or a minimum. And the way we do it is, we do the second derivative. Okay? So we know dy dx is that. So we do d2y by dx squared. Okay, so we differentiate it again. If we differentiate this again, you bring the 2 down, so you get 6x. And then there it becomes minus 6. Okay, the x goes. And then you literally put the values in. So for this point here, you say, look, when x is 0, d2y by dx squared is equal to 6 times 0 minus 6. And that's equal to minus 6, which is less than 0. Now, if it's less than 0, it doesn't matter what it comes to, okay? It could be minus 100. It doesn't really matter. If it's minus, you know it's less than 0. And if it's less than 0, it's going to be a maximum, okay? Okay? So basically, my point 0, 11 is a maximum. And then I put the other point in, when x equals 2, d2y by dx squared is 6 times 2, take away 6. And if you work that out, that turns out to be 6. Now, because that is greater than 0, okay, and again, it doesn't matter what it comes to, the fact is it's greater than 0, that shows that it's a minimum. Okay, so 2, 7, and it's a minimum. Okay, so that's really important there to note. Okay, really important to note that when it's less than 0, it's a maximum. When it's greater than 0, it's a minimum.